Problem 3.15 from Chapter 3 of Taylor's Classical Mechanics. This is a center of mass problem. It's a fairly simple problem. So let's just start by writing out exactly what we're given. And we know that M1 is equal to M2 and M3 is equal to 10M1. So we have a formula for the center of mass, and that is this vector is equal to 1 over M. That's big M, that's the total mass. That's each mass times its vector point location. So in our case, we have M1 times R1, which is going to be 1, 1, and 0, plus, because of the summation that we have going on here, that's going to be M2 times R2, which is 1, negative 1, 0, and plus M3 times R3, which is going to turn out to be 0, but we'll write it here anyways. And we know that our total mass is going to be M1 plus M2 plus M3, which is going to be M1 plus, we know that they're equal, so we're going to have M1 plus M2 is the same as M1 plus M1 plus 10M1 equals 12M1. That's our total mass, so we're going to put that in the denominator. Now, multiplying out, we're going to end up with M1, 0, plus, we know that M2 is equal to M1, so we can go ahead and put M1 in there. It's going to be a negative M1, 0, and then that 0 vector is just going to go to 0. All of this divided by 12M1 is going to give us that center of mass location. So adding these vectors together, we're going to have M1 plus M1. That is going to equal 2M1. M1 minus M1 gives us 0, 0. All of that divided by 12M1 is going to equal the vector of 1/6, those M1s will cancel, 0 and 0. And that is our center of mass vector. Now, we can do all this on a graph and get an idea of how everything works out. So we're going to have our R1 at 1, 1, 0. And the 0 is just signifying that this is the XY plane. All those Z values are 0. So we're only talking about a two-dimensional center of mass problem here. So you're going to go over to 1, 1, 0. And then 1, negative 1, 0 is, this is where your M1 is. M2 and M3 lies right there. Now you can see that there is an axis of symmetry here right along that x-axis. So, based on the symmetry, we know the center of mass is going to lie somewhere on there, and that is confirmed in our vector. So that's going to be placed somewhere around 1/6 is going to be our center of mass.